My name's Simon deGraaf, and the topic of this presentation is seasonality of reproduction. The key points that I'd like you to take home from today's presentation is the learning about what the function of seasonality of reproduction is in, well, all species, but for you it will mainly be of relevance to the sheep. To understand what the moderators of seasonality are, so what are the things that change seasonality or that stimulate them to occur, and then I'd love for you to understand what the physiological basis for the moderation of seasonality is. So what is seasonality of reproduction? Well, it's the idea that the cycles of reproduction are seasonal in some species. What that means is that some species are able to reproduce at certain times of the year, and then at other times of the year they're just not able to reproduce. Now, the reason for this is that it's a survival mechanism and it enables species to propagate efficiently. So, I guess more specifically, what that refers to is that offspring need to be born when the environmental conditions are most favourable. So this tends to be spring, and the seasonality of reproduction allows for reproduction to only occur at a time so that the subsequent offspring are produced or delivered in spring. Now, in most of the domestic species, it's been bred out of to a reasonable extent. So cattle, pigs, dogs, these are fairly non-seasonal species now. But for sheep and goats and horses, poultry, they are quite seasonal. Cats, not such of an issue probably for most people that are listening into this presentation, but they're also quite a seasonal animal. Now, what is interesting is that animals which are quite, or that aren't particularly seasonal rather, so say for example pigs, if they do go feral, then they do bring that seasonality back into their systems over time, and that's because they need to adapt back to the less stable environments which they would have if they were still in, for want of a better word, captivity. So wild pigs in Australia, they're highly seasonal. It's important for you to know that there are sex and breed differences to seasonality. So for a lot of species which are seasonal, and this goes for sheep as well, their males tend to be fertile all year round, whereas females are all or none breeders. Now, when I say that males remain fertile all year round, this doesn't mean that they're at peak reproductive capacity, and there is some seasonality of reproduction in those males, but they are able to reproduce out of what we would consider season. Now, some breeds are less seasonal than others. So of particular relevance today is the merino. So the merino is less seasonal than British breed sheep. What this means is that, as you can see in the graph there, which is a stylized representation of what happens. It's not a literal graph based on measurements. But what it shows is that there are more merinos which are able to still be cycling, or in this case the y-axis is ewes ovulating. They are able to remain in season or continue to ovulate over a longer period of time than those British breeds that have a very sharp drop off. Now, obviously this is not a perfect graph, as we know that there are plenty of merinos and British breeds that are cycling in January each year and December as well. So it's again, it's just a kind of a tool for you to understand how this seasonality can change depending on the breed which you have even within a species. Now this table here shows some of the species differences in seasonality of reproduction. All of these species are seasonal, and all of these species give birth during spring, but it shows what the link is between their gestation length and the time of their breeding period. And what you will see if you do the maths is that The breeding period is a couple of months before, in the case of the dog and fox, a couple of months before spring. And that's because their gestation period is only a couple of months. Now, if you have a gestation period which is 4 to 5 months and you need to give birth during the spring, then your breeding period is going to be in the autumn, which is what you see for sheep and goats. For cows and horses, which with a longer gestation period, their breeding period is in the spring or the summer, so that the fetuses are able to develop over that period of time that they need to develop, and they're going to give birth at the right time of year, which is again in spring. Now, when we talk about initiation of breeding, it's really important to get an idea of what causes that initiation, and it is an environmental stimuli. So some of the terms which we use are ultimate and proximate stimuli. Now, the ultimate stimulus is the environmental trigger related to survival of offspring. That's what we've already spoken about over the last couple of slides. So the temperature or the nutrition in spring tends to be the most appropriate for offspring to survive. So the ultimate stimulus is that survival ability for offspring. But the proximate stimulus is the trigger which tells the animal to breed, to enable them to give birth, to meet that ultimate stimulus. Now, there are obligatory proximate stimuli and there are modifying proximate stimuli. So the obligatory factors, this is the major proximate stimulus underlying seasonality and will always cause breeding to start or stop. And in almost all cases, this is day length. So you will, in the subsequent slides, hear the terms short day breeders or long day breeders. And this means that an animal is breeding or initiating breeding activity dependent on whether the days are getting shorter or getting longer. Now, modifying factors can modify the precise time of breeding, so things like temperature or nutrition, but these are secondary to the obligatory factors, which in almost all cases is day length. Another word for day length is photoperiod, and this is the first factor that regulates breeding season that I'd like to go into in a little bit more detail. Now, it's not the day length itself which is the major proximate obligatory stimulus, it's the day length change. So it's important that the animal is undergoing the change. And we know this because if you just take an animal which is in certain light conditions or day length conditions and then pop it into a light room which has a completely different day length, either dramatically shortened or dramatically lengthened, you don't automatically get the animal responding. They need to go through the change in that day length. So as I mentioned before, animals are long day or short day breeders, and for sheep, these are short day breeders. Now, the more extreme the latitude, the more extreme the seasons, and that means the more extreme the seasonality that we see in the animals which are at these various latitudes. Now, the example here in this little graph is one of sheep kept at a number of different latitudes. A merino sheep kept at either the equator or at about 28 degrees south, or which happens to be Queensland, or we have merinos here in Tasmania of 41 degrees south. Now, it's not immediately apparent, I admit, from these two graphs here that the merinos in Tasmania are more seasonal, but I'd say to you to have a little bit of a look at this line here, that it has a steeper curve than this one over here. And what that's indicating is that animals are more quickly transitioning between being in season or cycling and being non-seasonal. Now, what happens when there's constant day length? And the revealed panel that we have here gives us an indication of what occurs. So on our other two panels, where we had merinos kept at varying degrees of southerly latitude, you see that with the black line, we've got percentage of ewes which are cycling. Now here, where we're at the equator, where there's no change in day length, we actually get breeding all year round, or no seasonality. Now, what can happen in these situations is that you have some degree of modification which occurs from one of the modifying factors, and that becomes obligatory. So you could get a degree of seasonality, probably not down all the way to zero, but there might be some still changes in the percentage of the flock that would be ovulating. And you see that to a certain extent in this particular example, where there are still peaks and troughs, but overall you always have over around about 60% of the flock ovulating. Another one of the factors which can regulate breeding season is temperature. Now, generally it does not have any direct effects, although it may have an indirect effect through nutrition. But in Australia, what we would probably see it having more of an effect on is through heat stress. Now, heat stress can do all kinds of things, and traditionally we would consider it to be mainly affecting the male. So, it affects the libido, it's changing spermatogenesis so that the animal is having abnormal sperm being outputted. But we know now that there is more and more of an impact on the female as well. So the follicular fluid that the egg is growing in just prior to ovulation, that can be affected by the heat which the animal is exposed to. And if that egg is of poor quality, then you're going to have problems with early embryo development and a greater chance that that embryo is not going to survive through to implantation and subsequent birth. We've already mentioned nutrition to some degree. It's a modifying factor. Severe undernutrition can delay seasons. You can get silent estrus. You can get cycles where estrus is displayed, but there might not be an ovulation. And if there are specific nutrients which are lacking, you can sometimes get complete infertility. Now, you would know that flushing can improve fertility, but it doesn't have an effect on timing of breeding activity. So overall, you are not going to be able to recover the ability of a highly seasonal animal like the sheep to start ovulating just because you flush the animal. A really interesting one is social stimuli. This is a modifying factor which is used to some degree in sheep through the male effect, or what we would call the ram effect. So here is where you would expose rams back to ewes after a period of isolation. Usually we always quote in textbooks that it's 6 weeks, 2 kilometres separate, no sight, no sound, no smells of the rams. And when you reintroduce them, the females can come into estrus, and that estrus will be synchronized. Interestingly, females can also influence male reproduction. So if you introduce females back to males, if they've not been exposed before, particularly if they've not been exposed for a long time, so in a similar way to separating the sexes if you want to get the ram effect, you do get an increase in the activity of the hypothalamic pituitary gonadal axis, which we cover in another one of these presentations. Something to know is that prior to full expression of estrus and correct reproduction, that means a corpus luteum functioning correctly, you need to have a period of progesterone priming. So what that translates to is sometimes the first estrus, which can occur after a period of anestrus, of not cycling through the non-breeding season, unless there is some progesterone which is being delivered through CEDA or through a previous cycle where there hasn't been estrous activity, you won't get that full functionality of the reproductive tract and the reproductive system. Here we have a summary of all of the different factors that we've been speaking about for the last few minutes, plus another one. And what I think this is trying to say, or what I know that I'm trying to say, is that photoperiod, social cues, nutrition, temperature, and then the one that we haven't spoken about, stress, all of these things can have an impact on the GnRH pulse generator. And as you'll have learnt or will learn in one of the other presentations in this series of lectures on sheep reproduction, it's the GnRH pulse generator which controls the whole reproductive axis, the hypothalamic, pituitary, gonadal axis. So any of these environmental stimuli which affect the GnRH pulse generator, you can affect reproduction. And it's the photoperiod, the big one, that's the thing that we really want to cover now to speak about how that is transcribed in the body of the animal to affect seasonality. The important structure in the transcription of the environmental stimulus of day length is the pineal gland. So the pineal gland is what is referred to as a neuroendocrine transducer. And what it does is it takes a neural input and transcribes that into an endocrine output. So it's producing the endocrine output of melatonin, and it produces this at nighttime. And it's melatonin which affects the GnRH secretion, the GnRH pulse generator, which I've been referring to, and thus the FSH and the LH levels in the animal. Now, melatonin has a positive or a negative effect depending on the species. So high melatonin levels stimulate GnRH production in short day breeders, but in long day breeders, the melatonin inhibits those GnRH levels. If you take out the pineal gland, then you completely remove the ability of that animal to register day length. They are unable to decipher it at all. So in the sheep, breeding does continue, but it's at random with regard to day length. It's kind of like being on the equator, if you remember back to that earlier slide. And just like when you're on the equator, there can be a modifying factor such as nutrition or perhaps the social factors that we've spoken about. These are the things which might synchronize or alter breeding season. Now, if we really want to get into the nitty-gritty of how the pineal gland is acting as a neuroendocrine transducer and the entire pathway of how photoperiod is transcribed, we can take a look at this diagram here. Now you'll see the different steps in this little box down the bottom. So in the first panel, we've got anestrus. So this is long photoperiod, so the spring or the summer. Now you've got lots and lots of light coming in here because it's a long photoperiod, and lots of light means lots of stimulation of the nerves or the eye, and this is transcribed down through these different structures into the pineal gland, and this is causing a high amount of inhibition of the pineal gland. So that means low melatonin. It seems a little counterintuitive. Maybe you'd think that if there's lots of excitation of the neural pathway, then you should get lots of production of the subsequent hormone, which is linked to that pathway, but this is not the case. It's an increase in inhibition when you've got lots of excitation of that pathway in short day breeders. So this means low melatonin. Low melatonin means low GnRH. Low GnRH is low FSH and LH, and that results in anestrus. But if we then move to the shortening day length, so short photoperiods, so this is in the autumn, then you get low amounts of light. That means low firing of the retinal nerves. That means low excitation of this neural pathway. and that means that there will be a decreased inhibition of the pineal gland. Decreased inhibition means high amounts of melatonin, high amounts of GnRH, so FSH and LH levels are boosted, and you get that cyclicity. So what are the key points that I'd like you to take home? Well, I'd really love you to know or remember that seasonality exists to benefit the survival of offspring. So we're trying to get, not we, but the animals are trying to produce offspring at the optimum time for them to survive, which is the spring. Seasonal breeders, they respond to changes in day length. And it's this day length or photoperiod which is transcribed by the pineal gland. And the pineal gland produces melatonin. Melatonin is the key there to seasonality. It alters the GnRH levels and subsequently alters gonadotrophin production and then estrogen, testosterone levels, that kind of thing. So if you want to alter seasonality, you want to alter melatonin levels if you're going to do it artificially. And that's where Regulin comes in, and that's something that we're going to speak about in our next presentation on changing the reproductive cyclicity of animals.